Hey everybody, review time. I'm going to fly through this really quick, but my idea for you, write down, so I'm going to go by section, covalent compound and ionic compound. If you just write down this brief summary, this is everything you need to know for the test, all summarized. There's no useless information here. If you have all this information down, ace the test, no doubt about it. I'm going to go quick, so you have to pause a lot because I want this video to be short, so it will upload quick and you guys can get a hold of it. So covalent compounds. If you have covalent compounds, if you see something like this is covalent compounds because these are sharing electrons. When you see bonds, each bond represents 2 electrons being shared. So in total, this right here, there's 2 bonds. So it's going to have a total of 4 electrons being shared. 1, 2, 3, 4, just like that. Each bond represents 2 shared electrons. With covalent compounds, they share electrons. That's the key word with covalent compounds. They share electrons. They can only occur between nonmetals, 2 nonmetals, so the top right of the periodic table. When you name them, you always have to use prefixes, and they have to end in "ide." So an example would be like NO4, it have to be nitrogen tetraoxide. So the "ide" has to end in "ide, and I get the tetra from this 4 right here. So nitrogen tetraoxide. A bad example, if you had NO and you just wrote nitrogen oxygen. No, that is not right. It would have to be nitrogen monoxide, because you have to use this prefix right here, and you have to end it right there in "ide," and that would work just perfect. So covalent compounds, that's all the info you need. You can pause, write it down. If you write it down section by section, this is the only thing you will even need for the test, and it will be glorious. Okay, our next one is ionic compounds. If you see a picture like this, that's representing the transfer of electrons. This Bohr model, this atom, is transferring this electron to this atom, to this Bohr model. So that's representing a transfer, and therefore it is ionic. The key word to look for with ionic is transfer. It's not shared, not trade, nothing like that. It is transfer. They are transferring electrons with ionic compounds. Another picture for ionic compounds looks like this. So these are the Lewis dot structures. What this is showing is magnesium. And magnesium is giving or transferring its electrons to the chlorines. So you see it's transferring these different electrons to the chlorines. This is super secret stuff. It's straight off the test. So this will help. This diagram will help you a lot. Transferring those electrons to the chlorines. Now as far as what creates ions, what the different ions are, groups 1, 2, and 13 on your periodic table. If you look at your periodic table, group 1, 2, and 13. These all lose electrons, get a positive charge, and become cations. An example would be magnesium. It loses 2 electrons, gets a 2+ charge. Groups 15, 16, and 17, these all gain electrons, so they end up with a minus charge. An example, nitrogen would gain 3 electrons and get a -3 charge. And one thing I don't have up here to remember, ionic compounds only occur between metals and nonmetals. So it has to be something from the left side of the periodic table or the center of the periodic table with something from the right side of the periodic table. It's compounds and ionic bonding. Lewis dot structures. So when they are by themselves, remember you have to go right, left, top, bottom. So for aluminum, it would be right, left, top, because it only has 3 valence electrons. You wouldn't want 2 of these to be together. That would be wrong. Got to have them all spread out. Right, left, top, bottom. Right, left, top, bottom, right, left. So that's why there's 2 on the right and left, because that's the order it goes in. It'll make it symmetrical, which will be nice and awesome. If they are bonding together, what you need to do when they bond together, write down this example. It will help you a lot. You have CF4, so you have 1 C, it has 4 valence electrons, and you have 4 Fs, 1, 2, 3, 4. They each have 7 valence electrons, so they share, and everybody ends up with 8. And this bond is supposed to connect to this electron. I just drew it poorly. So write down this example, and that is an example of CF4 carbon tetrafluoride. That will serve as a good example of a dot diagram. And here there are 8 electrons being shared. 2, 4, 6, 8. So that is Lewis dot diagrams, Lewis dot structure. Please write down these examples. Please, please, please. That's why I'm doing this. It will help. Write them in your notebook so you can use them tomorrow. Valence electrons. Remember, valence electrons are the electrons found on the outermost layer of a Bohr model or of an atom. So if you look at this Bohr model, it has a total of 1, 2, 3, 4, 5, 6, 7 electrons, but it only has 5 valence electrons. 1, 2, 3, 4, 5. You only count the ones on the outer layer as valence electrons. Valence electrons are based on group. So if you look at your periodic table, groups 1 and 2, which are the columns, have 1 valence electron and then 2 valence electrons, and you skip the middle ones. Get over to group 13, and it's 3, 4, 5, 6, and 7 valence electrons as you continue through there. So it's just based on the column number. If you see something like this, the best way to solve how many valence electrons, if you're just given the electron configuration, is you find out what element it is. So you go find 2p5, see what column it's in, and that's how many valence electrons it has. The other thing you could do is whatever is the biggest number, the biggest big number in here, so like this is 2 and 2, you add its small numbers together. And that can get kind of confusing, but it would be like 5 plus 2 equals 7, so you'd know it has 7. My theory is just go find what element it is and look at what column it's in, and that'll tell you the number of valence electrons. This is fluorine, so 1s2, 2s2, 2p5. That gives you fluorine, and so fluorine's in column 17 or group 17, so you see it has 7 valence electrons. Okay, electron configuration. Don't have time to do a lot of practice problems here, but if you want, this thing is awesome right here. You could even like print this all off. If you come to my room in the morning, I may print all this off for you and give it to you, and you can quickly glue it in your notebook, and then boom, look at you, you're prepared. This is showing you what the value of each thing is on the periodic table. So it's like 1s1, 1s2, 2s1, 2s2, 2p1, 2p3, etc., etc., and it shows you exactly what each element is worth. Remember with electron configuration, say you end at 3p4, you see this element. To write the whole configuration, you find out you end here, and then you just fill in everything that came before. This right here is the exact order that you always go in. So if you end up at 4d, you know that 4d, say you did 4d5, then you know everything that came before 4d5 has to be full. So it would be 4d5 and then 5s2, 4p6, 3d10, 4s2, 3p6, 3s2, 2p6, 2s2, 1s2. So you just kind of go in reverse. You can get all this info written down. You can take a picture of it. You can have me print it off for you. You can print it off, whatever, if you can figure out how to print it off from the video. I don't know, but if you just go back, find out where you end, so like 6s2, and then you would just work backwards. So that is electron configuration. Polyatomic ions. This is our second to last one. These work like the crisscross method. You have them all written down in your notebook. You just got to be able to recognize them. Anytime there's 3 or more elements, like if it was Mg and oxygen and hydrogen, you know there's a polyatomic ion in there somewhere. What you do is you find out the charge of your first element, so magnesium is 2+. Then you find out the charge of your polyatomic ion, which for hydroxide is 1-. Then you crisscross, so you have 2 hydroxides and just 1 magnesium, like that. Now, more super secret information for watching this video. These are the 3 polyatomic ions you should highlight for the exam and keep your eye out for. Hydroxide, OH-, sulfate, SO4, 2-, and nitrate, NO3, 1-. Highlight those, keep your eye out for those. Those all 3 appear on the exam. So look back at the polyatomic ion video if you need more practice. Finally, VSEPR, these are the shapes. These are the 3 shapes you need to know for the exam. You have bent right here. It's got the lone pair. Sometimes they will draw like a little bubble here around the lone pair. Don't let that confuse you. It's still bent. Trigonal pyramidal, remember, it kind of looks like a triangle, so that's fun. Trigonal, triangle, pyramid, triangle. And then tetrahedral, it's got 4. You ever played Tetris? Tetris, that's supposed to be a square. You know how all the shapes of Tetris all have 4 squares? Ooh, and then they have like a T shape, you know? Oh my gosh, this is like the worst drawing I've ever... Oh my gosh, it's embarrassing. So, but Tetris, they all have 4 squares. So 1, 2, 3, 4. Those are the 3 shapes you need to know. Write those down. My biggest encouragement would be go back and write down what was in each of these slides. It'll only take a few pages of your notebook, and then that's the only pages you'll have to look at for your test. And it'll be glorious. If you come by my room in the morning, I may just be nice enough to print this all off for you. So that's our review. Go through it, pause, write. Good luck on the test tomorrow. It's going to be awesome. I'm out.